Hello, welcome. In this video, I am going to solve the step-by-step walkthrough about one of the popular multi-criteria decision-making methods, known as TOmada de Decisao Interativa Multicriterio, an acronym as TODIM, which means in Portuguese Multicriteria Interactive Decision-Making. First of all, I will discuss the procedural steps followed in solving the TODIM method. Step 1 is formulation of the decision matrix, where for solving decision-making problems, it needs alternatives and attributes in the form of a matrix. And next is step 2, which is normalization of decision matrix, which is done by using the normalization formulas based on the beneficial and non-beneficial attributes. The formulas for the beneficial and non-beneficial attributes are shown here. Then, next is step 3 is finding the relative weight criteria. Here the weights can be estimated by using the standard procedures such as subjective weighting methods or objective weighting methods. Among the weights, WR is the maximum of the weights, whereas WC is the current weight of the particular attribute. Then, next is step 4, calculation of the dominance degree of the alternative. Here, the comparison needs to be done from one alternative to another alternative in the form of subtracting one alternative value to another alternative value for all the attributes, and later, depending the value, it is used with the relative weight and was seen in the formula here. Then next is step 5, estimation of the overall dominance degree of alternative. By using the formula from the dominance degree of alternative values, this need to be calculated. Final step is, based on the overall dominance degree of alternative values, descending order of their dominance scores, and the alternative having the maximum dominance score becomes obviously the best choice. Let's solve the TODIM method step by step here. Consider an example. For material selection, for a cryogenic storage tank, for transportation of liquid nitrogen, where there are 7 alternatives of various materials like aluminum, stainless steel, Inconel, and titanium, and 7 attributes. Among the attributes, toughness index, yield strength, and Young's modulus are the beneficial attributes. Density, thermal expansion, thermal conductivity, and specific heat are the non-beneficial attributes. Here, using these weights, which are calculated by subjective weighting methods or objective weighting methods like AHP and entropy, as this matrix is the initial decision matrix for solving the TODIM method. In the second step, normalization by using the based on the beneficial and non-beneficial attributes. First, the formula is applied to the beneficial attributes. Here in the K5 cell, it is equal to 75.5 divided by the sum of all the alternative values. Here, by using the dollar symbol for freezing the series for all the values in the column, since the sum is used in the denominator for all the alternatives. Then drag the cell to all 7 alternatives to get the corresponding cell values. Similarly, for the second attribute, yield strength is also just dragging the cell and double-clicking on the cell to change the denominator value to another cell reference. Similarly, the same for Young's modulus attribute also. Select the 2 cell, then drag the cells to all 7 alternatives to get the corresponding cell values. Now the beneficial attributes normalization has completed. Then, going to non-beneficial attributes normalization. For this one, we have a formula where the value is not direct, it has to divide by 1. So, for this one in the bottom, create the calculation for the 1 divided by the corresponding cell value. Then drag the cell to all remaining 3 attributes to get the corresponding cell values. Simultaneously, drag the cell to all 7 alternatives. Now, go to N5 cell and use the formula, is equal to 0.35714 divided by the sum of all the alternative values. Here, by using the dollar symbol for freezing the series for all the values in the column, since the sum is used in the denominator for all the alternatives. Similarly, for the 5th attribute, thermal expansion is also just dragging the cell and double-clicking on the cell to change the denominator value to another cell reference. Similarly, follow the same procedure for the remaining cell. Now the normalized decision matrix of step 2 has completed. Next, for the calculation of step 3, WCR, first need to estimate the maximum value from the weights, and that value is WR. For WCR, WC divided by WR, here WC is the current attribute weight divided by maximum weight. In this case, it will be 0.28 divided by 0.28 and equal to 1, then drag to other columns to get the corresponding WCR value for the other attributes. I took a lot of time to read and understand the method, solve it step by step, and thoroughly prepare this video so that you can easily solve it. Please donate at least $5 if interested. I will share my PayPal or UPI address once you email it to me. It is your choice, and I can also provide the Excel template at no cost. If you need this Excel template for your reference or to verify your research data, please email me at vidrcaprojects@gmail.com. Next is step 4, calculation of the dominance degree of the alternative. For this, first calculate the difference of the one alternative with respect to other alternatives for all the attribute values. Example: A1 with respect to A2, A1 with respect to A3, A1 with respect to A4, and so on. For this one needs to use the subtraction formula for the normalized decision matrix, K5 cell to minus K6, since K5 is common for all alternatives, locking it row-wise by using the dollar symbol before the 5. Next, drag the cell to all remaining 6 attributes to get the corresponding cell values. Then, drag the cell to all 6 alternatives. Now, using a conditional formatting to identify the cells which are less than 0, and those are negative values which are highlighted in red color. Since, in the formula there are 3 conditions, equal to 0, greater than 0, and less than 0, this will help us in identifying the cells. Go to S17 cell. Here the formula is less than 0 need to be used for calculation. The theta value, attenuation factor values is considered 1 here, is equal to -1 divided by 1, multiplied by square root of an absolute of, because there might be the negative value inside the square root, so using the absolute function's abs. Summation of the WCR values, and using the dollar symbol fixing the row, multiplied by K17 cell the corresponding value, and then divided by the WCR value for the first attribute and locking the row with dollar symbol, and hit enter button to get the value. Next, for the T17, the value is greater than 0, need another formula, is equal to square root of the WCR value, and then locking the row, multiplied by L17 cell and whole divided by summation of the WCR values, and using the dollar symbol fixing the row, and hit enter button to get the value. Now get the values for the greater than 0 and less than 0, wherever the less than 0 cells are, they're just copying the formula. Since the formula is dynamically designed, depending on the corresponding cell, it will be adjusted so you can cross-verify it. Similarly, do the copy for the greater than 0 cell also to get the values in the corresponding cell. Wherever 0 is there, place the values as it is 0 there also. Now, summation of the attributes for all the alternatives need to be calculated in the AA17 cell. Then drag the cell to all remaining all alternatives to get the corresponding cell values. Do the summation of all alternatives to get a single value minus 30.138. Similarly, follow the same procedure for the next alternatives also, like A2 alternative to A1, A2 alternative to A3, and so on. Need to get the values for the other 6 alternatives A2 to A7. See the quick walkthrough here. Here, just consolidating the all dominance degree values for A1 to A7 alternatives. Next is step 5, calculation of the overall dominance degree of the alternatives, is equal to M75 cell minus minimum of the all alternatives, here using $symbol to fix the range since it was common for all the alternatives, divided by maximum of the all alternatives, here using $symbol to fix the range since it was common for all the alternatives, minus minimum of the all alternatives. Then drag the cell to all remaining all alternatives to get the corresponding cell values. Calculation of the rank is the final step, is equal to rank of the corresponding cell, comma the range of the value and using $symbol to fix the range, and just hit enter. Then drag the cell to all remaining all alternatives to get the corresponding cell values. Finally, the third alternative is the best alternative in the material selection for the cryogenic tank, that is SS301FH material is the best material. Thanks for watching the video.